Hello everyone. In this lecture, we will do some numericals based on electric fields. Example 1 says ABC is a right angle triangle with AB is equal to 0.4 meter, BC is equal to 0.3 meter and CA is equal to 0.5 meter. Point charges of magnitude plus 5 microcoulomb and plus 3 microcoulomb are placed at A and B respectively. Question says find the resultant electric intensity, which means only the magnitude at C. So what we'll do here is we'll look at these points. We'll call them as points A, B and C. In a right angled triangle, hypotenuse would be the longest side. In this case, it is CA. So if this point is A, then this point should be C and this should be point B, such that AC is given as 0.5 meter, AB is given as 0.4 meter and BC is given as 0.3 meter. The charges which are placed are a charge of plus 5 microcoulomb at A and plus 3 microcoulomb at B. So charge here is plus 3 microcoulomb and charge at B is, charge at A is plus 5 microcoulomb and charge at B is plus 3 microcoulomb. So the question says find the resultant electric intensity at C. So at this point we need to find electric intensity. As seen in previous lecture, the charges at points A and point B will create their own fields. So the point C, the charges at point A and point B will create their own fields, and we need to add these two fields by vector addition. That is called as principle of superposition of vectors. So in this case, let us find the fields which the charge create. Now, since the charge at point A is positive, its field will be going out radially. The field here would go out like this. So we'll call this as E suffix A. Similarly, the field, we'll call this as E suffix A. Similarly, the charge at point B creates its own field, and since even the charge at point B is positive, the field goes out like this. So we will call this field as E suffix B. So let's find what is EA and EB separately. So here EA is given as K Q by R square, where K is 9 into 10 power 9 into Q. It's from point A, so it will be 5 into 10 power minus 6 by R square. So we are trying to find the field at the point C because of charge kept at point A. So distance would be 0.5 the whole square. This is equal to 9 into 5 into 10 power 3, and this would be 0.25, which is as same as writing 25 into 10 power minus 2. So from here 5 ones are 5 5s are. So what remains would be 9 by 5 into 10 power 5 Newton per coulomb. This is E suffix A. In vector form, it would be along AC because the field goes away from a positive charge. Similarly, we will find out what is EB, that is equal to 9 into 10 power 9, which is K, and Q here is 3 into 10 power minus 6 by distance square that is 0.3 square. You will write this as 9 into 3 into 10 power 3 as it is, and this term here would be 0.09, which is same as writing 9 into 10 power minus 2. So from here this 9 gets cancelled, and finally what we get here would be EB is equal to 3 into 10 power 5 Newton per Coulomb. In vector form, this is along BC. So we have two vectors now. So the net vector, if we call it as E, so total vector is given as EA plus EB, that is we add them vectorially. This is called as principle of superposition of vectors. If you want to find its magnitude, in that case its magnitude is given by under root of EA square plus EB square plus 2 into EA into EB into cos theta, where theta is the angle between two vectors. So in this case it would be this angle, but this angle is equivalent to this angle. So if you call this as theta, then from this triangle you can find cos theta. So from this triangle cos theta would be equal to 0.3 by 0.5, that is equal to 3 by 5. So putting it back in this equation, what we get is, we get E is equal to under root of, this will be 9 by 5. Now from the equation we can pull out 10 power 5 outside, because every term here, whether it is EA or EB, both terms are they power 10 power 5, and we're squaring it here. There is 10 power 5 square here, the square here, the square here also. That will be common. If you pull that out, that will be 10 power 5 outside. So I'm just writing it's this value, not with the powers. So it is 9 by 5 the whole square plus 3 square plus 2 into 9 by 5 into 3 into cos theta was 3 by 5. This is equal to under root of 81 by 25 plus 9 plus this term here becomes, it is 2 into 9 would be 18 into 9, that will be 162. So plus 162 by 5 by 25. Now because there it's 5 into 5. Now if we take 25 as the common factor, it becomes 81 plus 25 into 9 would be 225 plus 162, the whole, it's the whole, okay, it's whole here also. By 25. If I solve this, the answer will be equal to, just solve and see it, it is equal to 4.33, and this 10 power 5 here also, this 10 power 5 here, not to forget it, 10 power 5 here into 10 power 5 Newton per Coulomb. So this is the required answer. Example 2 says two charges plus 16 microcoulomb and then minus 9 microcoulomb are placed 8 centimeter apart in air. Determine the position of the point at which the resultant electric field is 0. So we'll first draw a diagram for this. Let us assume that these two charges are placed at these two ends. We will call the points as A and then B. Let at point A the charge of plus 60 microcoulomb be placed, and let at charge B, let at point B the charge minus 9 microcoulomb is placed. The question says find the position of the point at which the resultant electric field is 0. We know that from a positive charge, the electric field lines will go out radially from positive charge, and for a negative charge, the field lines goes into the electric charge. So we can take a condition where we can take 3 points, a point in between A and B, a point to the right of point B somewhere here, and a point to the left of point A. So we'll find out at which points can the fields be 0. Now if we take some point between A and B, some point here, we will call this as point P. At the point of P, the field cannot be 0 because from a positive charge, the field lines will go out like this. We call this as E suffix A. It goes away from point P, and from minus sides also, the field line goes into the charge only. So even for minus charge, the field lines goes like this. So basically, the fields because of charges kept at points A and points B will add up. So somewhere in between points A and B, the electric field cannot be 0. The net field cannot be 0. Now we will look at a point to the right of point B. So we'll take some point here. We'll call as, say, point P. Now whether the field at this point can be 0 or not, we'll understand now. Now from a positive charge, the field lines will go out. It goes out like this. So electric field because of positive charge, we call as E suffix A. It goes out like this. And because of the negative charge, the field lines goes into the charge like this. So there is a possibility that at this point P, the field net field could be 0. So we'll assume this as the point P, so that distance from the point B to point P we call it as x. So the distance from point A to point P would be x plus 8 in terms of centimeter. So remember that in this case x is in centimeter and this also is in centimeter only. Since the net field at the point P is 0, it means in terms of magnitude, the fields EA and EB should be 0 in terms of magnitude. So you can say that EA is equal to EB in terms of magnitude. Now EA is given by, it is K into Q, which is 16 into 10 power minus 6 by R square, which is x plus 8, it's in centimeter, so into 10 power minus 2 the whole square. It is equal to here K as it is, Q here is as given here, it is 9. It will be 9 into 10 power minus 6 by x into 10 power minus 2 the whole square. This is what we get. And from here K gets cancelled, 10 power 6 gets cancelled, and even if you expand this, 10 power minus 4 and this gets cancelled. So finally what remains would be, it is 16 by x plus 8 the whole square is equal to 9 by x square. If you cross multiply and solve this, then 16x square is equal to 9 into x plus 8 the whole square. If you take root on both sides, then 4x is equal to 3 into x plus 8, or 4x is equal to 3x plus 24. If you bring this side, it becomes 4x minus 3x, which is nothing but x only. So therefore x is equal to 24 centimeter. This is what we get. Now to do it other way around, instead of taking the point to the right of point B, what if we take a point to the left of point A? That is, take a point to left of point A. So let this point be Q. We take a point Q. In this case, or I'll redraw this. There are two charges at point A and point B. It is 16 microcoulomb here. It is minus 9 microcoulomb at this point. Now we'll take a point to the left of point A. We will call this as point Q, such that the distance between these 2 points, that is point A and point Q, we call it as x in this case. So distance between point B to point Q would be x plus 8. So from here to here it becomes x plus 8 centimeter. Again, using the same logic as the previous case, even at the point Q, the net field is 0, which means the field because of A and B is equal. Now this is equal to K. Q here is 16 into 10 power minus 6 by R square would be x into 10 power minus 2 the whole square. That is equal to K 9 into 10 power minus 6 by distance is x plus 8 into 10 power minus 2 the whole square. So from here K gets cancelled, 10 power minus 6 gets cancelled, and also 10 power minus 4 gets cancelled here. So what remains would be 16 by x square is equal to 9 by x plus 8 the whole square. Again, if you cross multiply, then 16 into x plus 8 the whole square is equal to 9 into x square. Now from here, if you take a square root on both sides, it becomes 4 into x plus 8 is equal to 3x, which means if you solve this further, 4x plus 32 is equal to 3x. If you bring this term here, then what we get would be, we would get x is equal to minus 32 centimeter. So the assumption here is that from the point say A, the distance is minus 32. It means that since we have taken this as positive in our case, taken as plus x, so minus would be in this direction for the charge A point of view. So distance from this point would be as given here, it is minus 8 centimeter, which means minus means it's from point A towards point B, because we've taken the plus as this direction. So it will be from here, it will be some point here, such that this distance from this point A to this point would be 32 centimeter. But the distance from point A to point B is already 8 centimeter, which means it effectively means that from point to B it will be 24 centimeter, which is what we got in the earlier case also. So the point here in this case is to the right of point B. That is because what is happening here is, if you look at this, in this case this charge dominates, because charge goes as k q by r square. So to left of point A, this will have more contribution because the electric field goes directly as q. So look at some point here, this will dominate, and also at this side to point somewhere here, this is closer than this charge. So there can be no point this side where this will cancel it. Unlike to the right of point B, somewhere here, unlike this case, if we look at some point here, then what happens is the charge here is less than this in magnitude. Even though the charge B is close to this point P, but the effect of this is greater. So at some point here it may nullify it. That's the reason that the net field would be 0 to the right of point B. Example 3 says, figure shows 4-point charges at the corners of a square of side 0.02 meter. Find the magnitude of the electric field at the center of the square, where at the center the charge placed is 1 nanocoulomb. Now you all can do it as homework and see it. You all find the field which the charges at point A, B, C and D creates, and then add them by the principle of superposition of electric fields. The answer would be 6.36 into 10 power 4 Newton per Coulomb. So try this and see. Example 4 says, a charged oil drop is balanced by its own weight in an electric field of intensity 10 power 5 Newton per Coulomb. If the mass of the drop is 0.1 gram, calculate the charge on the drop. Also find the number of electrons removed from the drop. So what it says here is basically, if we look at an oil drop, now this is a very famous experiment. So if we look at an oil drop of certain mass m, then for this oil drop, because of its mass, the weight mg will act in down direction. Now because of this, the oil drop should accelerate and fall downwards to the earth's surface. But question says, a charged oil drop, it's already been charged, is balanced by its own weight in an electric field, which means this weight of the object is balanced by another force, and that force should be the electrostatic force. We'll call this force as, say, Fc. So it's the Coulomb force acting in the up direction. So only in this case, only if Fc balances mg, then net force would be 0. Now question says, find the number of electrons removed from the drop. In this case, if you want to find the direction of electric field, since from the electric drop, since electrons are removed, this drop would acquire a positive charge. So net field would be in this direction. I mean, the applied field would be in this direction. That is what is E. It's not required here to find out how does E act, but to understand, E acts in up direction. Now we know that the charge is balanced by equal forces. So it means that Fc is equal to m into g, but we know that Fc is given as q into E, it is equal to m into g. We learnt in the first lecture that the total charge is equal to plus or minus n into E. This is called as quantization of charge. So in this case, it's already given that we already know that this oil drop is charged positively. So therefore, we can say Q is equal to just plus n into E in this case. So putting it back here, what we get is, we get n into E is equal to m into g, or the number of electrons removed, which is n, that is equal to m into g into E into E. The mass of the oil drop is given as 0.1 gram, and we can write 0.1 gram as 10 power minus 4 kg, because 1 gram is 10 power minus 3 kg, it is 0.1 gram, so it becomes 10 power minus 4 kg into g as given as 9.8 in this question. So into 9.8 by the charge of electron is equal to 1.6 into 10 power minus 19 coulomb into the applied field. The applied field here is given as 10 power plus 5 into 10 power plus 5. We can write this as 9.8 by 1.6. We have pulled out these two terms, and the remaining would be only powers. So into it's 10 power minus 4. So minus 4, and it becomes plus 19 in the numerator and then minus 5. So this becomes 10 power plus 10, and 9.8 by 1.6 is 6.125. Therefore n is equal to 6.125 into 10 power 10. So if this much number of electrons are removed, in that case the oil drop would be balanced by its own weight. Thank you.